Okay, so let's start off by doing the graph right here. So we have a piecewise function. It's a little bigger here. We're going to go ahead and type this part in right there. X only if x is greater than or equal to 0. Only it's not put in exactly that way. There's a slightly different type of syntax you use. So in the first box here, row number 1, they're numbered up in the corner. You're going to put x. Okay, you'll see a little line. Go ahead and do that. And then to do the next part, the x is greater than or equal to 0, you're going to put in braces. So you have to hold the shift and just right of the P, just right of it. That will give you the two little braces, not parentheses. Okay? And then you can type in x, and then the greater than or equal to. Now there's a little keyboard down here, right? There's a keyboard down here, and then you'll see it might be hidden. If it's hidden, you just have to hit the little thing here that says show keyboard. That'll pop up. And then there's a greater than and equal to on there, and then you can hit 0. So that's how you do piecewise functions in Desmos. You have to use those braces. Put on projector mode. You have to use those braces, and that will let it know where to start and stop. In this case, just start and go to the right. Okay. So that's the first one. We good so far? Okay. All right, looks good, look good. And we could do the same thing for the second one on row 2. Very similar, only it's negative x. And then braces, hold the shift. We got those, and we're going to do x and less than 0. Now, when you do just the less thans without the equal to on them, you can use the keyboard because it's on there. It's right next to the M key, just to the right of the M key. They have the less than, greater than. But if it has the line underneath, the equal to, then you probably want to use the keyboard down below. So there you have it. There is that piecewise function. Okay. So in general, what would you say the shape of this graph looks like? Yeah, a V-shaped graph. So all of your graphs this week will have this general shape of this piecewise function. Now, it turns out there are a lot of reasons to have a function shaped this way that does this. Basically, it takes anything and makes it positive. So if you plug in a negative number, your answer is positive. So that's why all the x's here are negative, but the y's are positive. But if you plug in a positive number, that is also positive. So no matter what, if it's positive or negative, it's a positive number. Once we learn the mechanics of this, we can look at more realistic ways of using it. We gotta learn the mechanics first. So since this is so important, actually let's do the tables first. Okay, go ahead and click on the top row where we have the greater than equal to 0. Click on that top row, and here's a little bit of information you're going to use for now and for your project. Go ahead and hit edit list. The little gear says edit list. And there's 3 little icons that show up next to the function. And the first one is convert to table. All right, so go ahead and click convert to table. So if you ever need to have the x and y coordinates of any particular graph that you've already created, you can easily use that function there, and that will make a table for you. Now, as you can see, oops, it's undefined, right? Just like right here, these are undefined. Okay. But down below, yeah, 0, 0, 1, if you plug in 1, you get 1. Plug in 2, you get 2. Plug in 3, we get 3. And then same thing here for the one below. We can once again go to the gear and hit convert to table. And that'll give us that second table. There we go. It's undefined for these values because we're only looking at when x is less than 0. So it doesn't even plug in 0, 1, 2 because we said only look at less than 0. But for -1, we get an answer of 1. For -2, get an answer of +2. And you can continue the pattern without having the table do it for you. That means when you plug in +3, you get 3. You plug in -4, you probably get +4. Yeah. So there's an obvious pattern here that no matter what you plug in, your answer, the y, is always positive. And that's what this piecewise function is all about. And since this piecewise function turns out to be so useful, instead of having to write this over and over and over like we just did, okay, and separately getting two lines, one for the positive like this, and then another one for the negative like this. Oops, not like that. Like that. Instead of doing separate like this, we can see like, you know what, this is basically the same thing. Just one's going up one, right one, up one, right one. This one's going up one, left one, up one, left one. But they're pretty much both going up, but then as far as the left, right, they go either to the right or to the left. Up one, right one, up one, right one, or up one, left, up one, left. So it has a slope-like feature to it where you can go either direction, depending on if you're going right or left. And because of all that, just to make it simple, we've come up with this special function that has these two bars on either side, and we call that absolute value. Absolute value. Okay. So let's take our graph and we're going to punch in now this symbol. Okay. So what we can do is get rid of this. I'm just going to X them out, get them off our graph. So it's a clean slate. And type in y equals. Now the absolute value is down below in the keyboard again. On the same row as the less than, equal to, greater than, equal to, is the absolute value. It has a little A inside for absolute value. So right above the big button, you click that and the absolute value bars show up. And then you can type in X. And you'll notice that is identical to what we just did. That whole piecewise function we just created above. You know, how to type in all this stuff, the if, the braces, and all that stuff. We just typed in one little thing with the absolute value on it, and it made the exact same graph. So this is like a shortcut. Instead of making that piecewise function over and over and over, you just type this in and get the exact same thing as you see here, and has the exact same slope. It's up 1 over 1, up 1 over 1. So it's got the +1 and goes to the right one. But then it has the up 1, left 1. All right. It also goes to the left. So it has exact same characteristics of the slope. But without having to write all that extra stuff. And you can imagine, well, if it's really just combining, you know, these two together, these two functions together into one, it has the exact same properties in the t-chart. It's just that the top value here is going to be kind of like this right here. -2 is going to be 2. -3 is going to be 3. So on. Continue the pattern. But then when you go positive, we don't have any more undefineds. It's just going to be, well, +1. That gives you 1. +2. That gives you 2. +3. That gives you 3. So it combines the t-charts as well as the graphs all into one t-chart, all into one graph, making it a little bit, or actually a lot easier to work with. And you don't have to do this, but if I went here and hit convert to table, you can see it has the positives and the negatives. All right, click on this and make it all done black. Okay, good. All right, let's see here. Anything else on here we need to look at? A domain and range we're not going to worry about right now, so don't worry about that part. Vertex. Let's see, black. The vertex is the point where the two diagonals meet. So in this case, this is the vertex, and it's at 0, 0. Everything that you do today will start at 0, 0. Okay, that's your vertex. And I've already mentioned, what is the slope of all these? So far, right, we have two slopes, like this. It's going to be up one, and it's going to be over one, but it can be right or left. It's going to go both ways. So we go up one, right one, up one, right one. We can also go up one, left one, up one, left one. So that should fill out A, B, C, D, and E. That's your slope. And that's the only thing that's really different compared to what you were doing before. The bottom number is going to be right and left. It's going to go both directions. So that should conclude the front. Leave your graph the way it is. Leave that there, so you should have just this on your graph right now. If you want to change to black, what I did is I put the mouse on the color and hold down the mouse key, and then it'll pop up different colors, and you can change it to black. It's black because it'll match what's on your paper right now. So when you go over to page 2, flip it over, you can see we have some graphs that already have a graph on there. That black graph is the absolute value of x. And what we're going to do is graph these other ones on top of it that have various different numbers like 1/2. This one has a negative 1/2. And see how does that change the graph. And we're going to use words to describe how it changes, like the words reflect, compress, stretch, steepness, the wide, is it narrow. By adding a 1/2 in front of our graph, how will it change it compared to the one that's already here right now? And this is what you guys will be doing tomorrow on your own. You'll have something similar. It'll tell you what to type in, and you just have to type it in and compare it to what's already there. So let's go ahead and type it in, a new row, y equals. And you're going to type in 1/2 x. 1/2 absolute value of x. So we got 1. Now the fraction key is the question mark key. The forward slash, so you hit 1 and then the forward slash, and that makes a fraction. And then 2. So there's 1 over 2. And then you have to hit the right key. The cursor's on the bottom right now. Hit the right key one time, so it's to the right of the fraction. And then, like we did before, hit absolute value of x. Now, how does this graph compare to the one that's already there, the black one? Right. First, let's copy it down. So it looks like it looks something like this. It goes the same in both directions, right? There we go. So what would be a good word to use to describe? Would be a good word to describe how this one is different compared to the one that was already on there? Yeah, it's wider. So down below, using some words, you can say something like the graph is wider. Some sort of adjective. Just describing how it's different. We know with the 1/2 it makes it wider. Good to know. And as you probably figured out, it has a 1/2 here. The slope is a half. It's up 1, right 2. Up 1, right 2. It's also up 1, left. So kind of like before where the slope is positive is going uphill. Very similar, not the same, but similar. Now, what do you think would happen if we put in a negative 1/2? What happens if we made this negative? Any ideas? What do you think would happen? So type in negative, see what happens to the graph. Yeah, same thing, but now it's going down. Kind of like how a negative slope goes down. Now the whole graph takes it down. But it's basically the same as when it was positive. Right, still has a slope of 1/2. It's just starting downward instead of upward. So this one, negative 1/2, it goes down 1 and then left or right 2. So down 1, right 2, down 1, right 2, back to the vertex at 0, 0. Also down 1, left 2, down 1, left 2. So very similar. So by making these tiny little detailed changes and seeing, well, what does this one little detail, when I change it, do to the graph, will let you learn, like, well, how to do it without using a computer. Like, okay, positive 1/2, it was just up 1/2, negative 1/2, now it's down 1/2. And then, of course, use words. How would you use words you use to describe this facing down? Yeah, the graph. When you say whoops, mathematically, I use the word reflect. Reflecting. Think about a reflection in the water. It's exactly the same. It's going the opposite direction. Huh. Not too bad. So repeat the same process. What do you think will happen with 3? All right, so you can always make a prediction and then go back over here and just double check and see if that's what you get. Blue. Hold that down, change to blue. All right, and I can make this a 3. And voila. It now has a slope of 3. So what would be a good adjective to describe this? It's no longer wider, right? So what is it? More narrow. So there we go. The graph is more narrow. Someone else might say steep. Okay, it's more narrow, it's more steep. Climbing up that mountain is just a little bit better because of the steepness. It's higher steepness. So the 3, or a bigger number than 1, is making it more steep. So we have a baseline of this printed graph that was a absolute value of x with a 1 in front, and we put a 3 in front and made it more steep. We put a 1/2 in front and made it half as steep. So just like when we were graphing, linear equations, the number describes how steep the line is. Now, without using the computer, what would a negative 3 look like? Same thing but reflected, and there you go. Now it's down 3, right 1, down 3, right 1, and down 3, left 1. So this is the idea that you can go through and just put these in on your, oops. Oh, that's right. Go down and put these in on your own, and you can figure out the pattern on your own. Nobody has to stand up here in front of you and show you the obvious that you can just by changing the numbers figure out, oh yeah, when I put a negative in front, it makes it go down instead of up. You don't need anybody to explain that to you. You can see with your own 2 eyes. Okay? So tomorrow when you get your paper, that's what you'll do. You'll kind of put these in, figure out the pattern on your own, and then you can just flip it over and do the problems all without any interaction except between you and the computer. The graph is steep and reflected. It's both. Steep because the number is a little bit bigger. Reflected because of the negative. So the negative and the number have 2 different purposes. There we go. So with that given, page 3 is blank. It's just be line paper. With that given, can you go through without using the computer and do 1 through 9? All right, and that's what you want to do. You don't want to get to here and say, okay, now let's plug in 2 and see what that looks like. All right, let's plug in 2, 1/4 and 2/5, figure out what that looks like. It'll take you too long. You don't need it at this point. You should be able to just look at this and say, okay, 2. Okay, that's going to be opening up, right, because it's positive, and 2 is the same as 2 over 1. And you can graph this using the knowledge you got from discovering it. You can graph it precisely, not kind of close, but exactly. Okay. And fairly fast. So you don't need a lot of time to finish this. You have it if you need it, but just in case. All right, so I'll leave you with that. Just remember that the negatives do open down. So a -2 means -2 over 1 down to left or right 1, right or left, I should say. So 1 and 4 are kind of like counterparts, kind of like on the previous page. And if your graphs aren't mirror images of each other, then something is wrong. It should be mirror images on the left and right hand side. On all of them today, the vertex is all at 0, 0. So 0, 0 is going to be a starting point. Tomorrow we'll throw in some different numbers in there. Those numbers that are new and different, those are going to move the graph different directions. And you'll find out which number and which way moves the graph, or we say translates the graph left, right, up, and down. Okay, so your goal again is to finish the back, have the front 2 pages filled out as well, and to make sure your name is on the back right now. I know there's a name for on the front, but please put your name on the back as well. It'll be easier to check off later. That's what the stamp will be. So put your name on the back side also. Okay. All right.